Any doubts here, Ben?
No, sir.
It's going well.
Yes, sir.
So, not many participants here. Yes, so, what do we do here in root locus? Yes, Himanshu, can you tell me what do we do here?
Yes, sir.
What is root locus design all about? Construction of root loci.
Basically, getting from open loop transfer function, getting closed loop loops,
We make use of open loop transfer function
and to
GSHS.
get closed loop loops.
Yeah, very good, very good. To plot the all possible locations of roots of no characteristic equation of
Yes,
closed
sir.
loop system or closed loop poles or
Yes, sir.
eigenvalues of closed loop system.
Yes, sir.
And this plot is obtained by varying one of the system gain for its full range from 0 to infinity. And normally we choose this as your open loop gain k as the parameter when we vary it from 0 to infinity. What can be all possible no positions or locations of the closed loop poles. The beauty of the method is we don't really require to construct the closed loop system and or closed loop transfer function and then obtain the characteristic equation solution of which will give us solution of which will give us closed loop poles. We really no don't do this uh, part, but simply by knowing the open loop transfer function we are able to do no obtain the possible places where roots will be no falling in s plane as k is varied, the roots of closed loop system. Good answer, Himanshu. So that is one important thing, right, friends? Let us move quickly here. Then we have seen some of the rules of no obtaining the root locus. We know that first rule is the root locus will be symmetrical about the real axis, right? Since we know the complex roots are also symmetrical about the real axis. No complex root can exist in isolation. It will be accompanied by its conjugate. So they by default become, they are lying symmetrically with respect to horizontal axis, that is real axis. Then we saw the number of branches of root locus is equal to number of open loop poles, and each branch originates at a open loop pole with k equal to 0 and terminate to either open loop 0 with k equal to infinity or proceed the branches n minus m branches proceed to infinity where they meet open loop zeros. So how many open loop zeros are present at infinity, Ben?
N minus M, sir.
N minus m open loop zeros are present at infinity because we know that branches will terminate only at open loop zeros, but the finite open loop zeros, which are m, right? If are less than number of the branches, then the rest of the branches n minus m would be proceeding towards infinity because open loop zeros are lying there at infinity. This many open loop zeros n minus m. Good. Rule 3 was about finding out which points on real axis lie on root locus. So we have this angle criteria used to develop this rule 3, where we have said that any point on real axis will be on root locus only when the number of open loop poles and zeros to the right of point is a odd number, right? That came out from the angle criteria. So to quickly brush it up, what will be the root locus for this transfer function GSHS? Yes, can we draw that? So let us get your S plane, right? This is your S plane. Now where are the open loop poles? One open loop pole is at origin, one is at -3, and one is at -4, right? And where are the open loop zeros? One is at -1. This is one open loop zero at -1. One is at -2. This is another open loop zero, right? So we have mapped all the open loop poles and zeros first thing, right? Now, how many branches root locus will have? Equal to number of open loop poles. So there are three open loop poles. So each branch will originate at an open loop pole when k is equal to 0, right? So each branch will originate at these three open loop poles with k equal to 0. Now, where does this branch goes? Now, this branch will go and terminate at this open loop uh, 0, right? All the points between 0 and -1, they will be on root locus because of the rule 3. The number is odd, right? Then this points between -1 and -2 does not lie on root locus because for this, the number of open loop poles and zeros to the right is what? Even, 2 here. Then these points again lie on root locus because here number of open loop poles and zeros are what? Odd to its right. The branch originates at -3 and terminates at what? -2, open loop 0 at -2. So show the arrow, the direction in which branch no progresses. Whereas again, no point between -3 and -4 on real axis will be part of root locus because the number of open loop poles and zeros to the right is even, right? 1, 2, 3, 4. Whereas all the points here beyond -4 on real axis, they will lie on what? Root locus. So you darken this part. Always remember, darken that part of real axis which no is part of the root locus. And here it proceeds to what? Infinity. This branch proceeds to infinity with k tending to what? Infinity. So this is how root locus will look like, or this is how the no details could be obtained. Any questions here, Ben?
No, sir.
Good. So we have done that, right? Let us quickly see. So how many branches here were moving to infinity? One branch that originated at -4 that goes and terminates at infinity, no merging into what? A open loop 0. One open loop 0 will be lying at infinity because n minus m here is 1. N is number of open loop poles, m is number of open loop zeros, so n minus m is 1 here. Good, very good. So once we are done with this, next let us quickly go to now the rule. Till now we have almost discussed, right? Yeah. The next rule states here the number of branches of root locus that tend to infinity do so along some asymptotes whose angles are given by this particular expression where q is an integer that starts with 0 and ends with n minus m minus 1. Okay, so the number of branches that terminate at infinity. So in the above case itself, right, there was only one branch that was terminating at infinity. So what will be the number of asymptotes? Number of asymptotes will be 1. Number of asymptotes actually asymptotes gives the direction in which the branches which are terminating at infinity will progress, right? The asymptotes are just to obtain in what direction these branches they have to progress, grow to reach infinity. Now that's what we have, and these angles would be obtained by this particular expression here. So let us see that now these asymptotes, when there are multiple asymptotes, they will have a center also. The centroid of asymptotes is given by rule number 5. The real parts of poles, sum of real parts of poles minus sum of real parts of zeros by number of poles minus number of zeros. So let us quickly set ourselves to find out what this rule number 5 is all about with this particular example no, to us. Now let us get started with obtaining the root locus for this. Let me get pencil. Yeah. So what will first step is what here, friends? Uh, Plot the open loop poles and zeros. So here, what is this given to you in the last bullet point here, Ben?
This is
What is
closed
this?
loop.
Yes.
GSHS.
No. What is this complete equation?
Complete is characteristic equation.
Very good. Complete is characteristic equation that you have to understand, friends, right? 1 plus whatever it is that on the right hand side of plus, right? That is your open loop transfer function here, right? So what is GSHS? Because for root locus, what do we require as starting point? Open loop transfer function GSHS. And here GSHS is equal to K upon S into S plus 1 into S plus 2. This is what you did first. Got GSHS known. Now plot the open loop poles and zeros. There are no zeros. There are 3 open loop poles at origin, then at -1, and then at -2. Right? So we have these 3 open loop poles. Now, how many branches will terminate at infinity here? Yes, Ben?
None, sir. At infinity, all three.
All 3, because there are no zeros, finite zeros, open loop zeros, right? At
Yes.
which these 3 branches, the 3 branches, each of which will start at a open loop pole with k equal to 0, right? 3 branches of root locus. So each branch will start at a open loop pole with k equal to 0. And which part of all the 3 have to terminate at infinity, because they don't see any no presence of finite open loop 0. Now which part of real axis will be on root locus? From 0 to -1, it will be on root locus. Do you agree with me, Ben? Because for
Yes,
these
sir.
points to their right, there is always one open loop pole. So show the direction. This branch moves in this direction, whereas this branch moves in this direction. Since now these 2 branches are facing each other, right? They are moving in opposite direction as k increases. How do branch progress? As k increases, right? Becomes no more than 0, the branches start moving, right, in S plane. And here they are facing each other. And this branch, again, no part of real axis between -1 and -2 will be on what? Root locus. Whereas all the points beyond -2 on negative real axis will be what? Part of root locus, right? So that is what we understand, right? We know that this branch is progressing is this direction on no real axis. Ben, can you tell me, will this branch leave real axis anytime? The branch that originated at -2,
No, sir.
because all points
It will
have
always
to be
submit
on
at
root
infinity.
locus, right?
Yes.
So this branch will remain on real axis always, right? So it will go on terminate at infinity. We will see. Whereas this 2 branch, as k increases, they left their no origin or no birthplace, and then they are moving right on real axis. But as k increases, they don't see any 0 here at which they terminate. So these 2 branches also have to move towards infinity, right? And infinity now means these 2 branches will enter in complex plane. They will leave real axis and will enter in complex, will become complex. Now at what point on real axis all this happens, we will see, right? But first let us understand rule number 5. That tells us how many asymptotes will be here for this open loop system. 3 asymptotes will be there, right? And what will be the angle of 3 asymptotes? Angle of asymptotes is given by phi a, right? And it is no obtained by putting n minus m, that is 3. What is n minus m here, friends? 3. Now you got phi A equal to now 2q plus 1 into 180 by 3. 180 by 3. And what is 180 by 3? 60 degrees, right? So 60 degrees into 2q plus 1. This is what you are getting, phi A. Now put the value of q. For q will start from 0. So q equal to 0. For q equal to 0, what will be phi A? Yes, it will be 60 degrees, right? Then for q equal to 1, what will be phi A? Yes, it will be 3 into 60, that is what? 180 degree. And for q equal to 2, right? Q will end at what, Ben? N minus m minus 1. And what is n minus m minus 1 here?
2, sir.
2, right? N minus m is 3 minus 1, that is 3 minus 1, 2. And for q equal to 2, what will be phi A? It will be 5 into 60, and 5 into 60 is what? 300, right? So there are three no asymptotes at 60 degree with positive real axis, 180 degree and 300 degree. Now, where are the three asymptotes meeting? The centroid of asymptote is given by this particular expression here, right? It's interesting but little lengthy. I can explain you about this also, how we are no bringing concept of asymptotes and these relations. I will tell you in a small video class. So as of now, just take this as what a rule, right? Stated no truth about development of root locus. So centroid of asymptote, centroid is given by this particular equation that tells minus sigma a, that is the center or the point where the three asymptotes will meet, is given as sum of real parts of poles. Now, what are real parts of poles? All the poles are real, minus 1, minus 2, and 0. So, sum of real parts becomes what? Minus 3. There are no zeros, so minus sum of real parts of zeros is 0, divided by n. Number of poles is n, number of zeros is m. N minus m is what? 3 minus 0, that is 3. So centroid minus sigma a is given by what? Minus 1. So where are the three asymptotes meeting? At this point. First asymptote has what angle? It has an angle of what? 60 degree. This is 60 degree, right? Second asymptote is at what angle? 180 degree. This is 180 degree, right? Third asymptote is at what angle? 300. This is what? 300, right? So in this way, the three asymptotes, right, at respective angles, they are having a common meeting point, centroid at what? Minus 1. And incidentally, here minus 1 happens also to be what? One of the open loop poles, not necessarily always. Here it is no coming out like this, right? So we got all the three asymptotes. Now, where do the three what does rule number 5 tells? It tells that the number of branches that terminate at infinity, they do so along the three asymptotes. So one branch is already moving along what? 180 degree branch. This branch 2 at 180 degree. Along this branch, along this asymptote, one branch is already moving, right? These two branches, right? One originating at minus 1, one originating at 0. These two branches will leave real axis somewhere. That point where they leave real axis is called as a break away point. That point is called as what? Breakaway point. We will see how to find out breakaway point. But let us say somewhere here, the two branches, they leave real axis. So once they leave real axis, how they do further move? One branch moves along parallel to this asymptote. This is one branch that has left real axis and is moving here. Another branch leaves real axis and moves no, parallel to this asymptote, right? So that is how its direction is given by the arrow. So these two branch, they terminate, they move to what? Infinity, right? They two move to what? Infinity, with k tending to what? Infinity. So this is what the root locus will look like, right? Any questions here, Ben? Anyone, friends? I would be happy if there are some questions what I did here. Have we got more participants? Now it's reached 43. Does this remind you something, Ben? 43 number? Ben?
No, sir.
Anyone, does something comes to your mind by seeing 43 as participants? Some updated friends of mine who are regular in reading newspapers, they may immediately jump and tell me what is 43 today. Anyone would like to tell? This is also your GHMC no election voting percentage, 43%. So Ben, we are meeting the no same GHMC scenario, right? They got polled 43%. We are also having 43 participants. Does the two things relate?
Yes, sir.
Right. So that is 43%. It's a very poor turnout. But surprisingly, when I was reading paper today, it tells that this was the highest percentage in last no few GHMC election. So even people got over that COVID fear and they came out and voted. So okay, leaving apart GHMC election, now we have this root locus before us. Any questions on root locus from 43 participants?
Yes, sir.
Please. Yes,
It's clear, sir.
it's clear. Someone is trying to say no question. Okay, you move on, sir. Okay, okay, friends. So here what we did, we got the three asymptotes. The rule number 5 we discussed in this particular case, how we deal with the branches of root locus which don't find finite open loop zeros to jump into that to get terminate, but they have to move to infinity. So these branches that move to infinity, they do so along the asymptotes, right? Each asymptote will be guiding how the root locus branch will further move as k increases, right? More and more. So that is what it was all about, rule number 5. Now then let us move to rule number 6. So one more question here. Friends, can you tell me, is this system always stable?
No, sir.
Why, Ben?
Root locus shows that.
Yeah, because two branches of root locus, after no certain value of gain k, are entering in the right half of the S-plane, right? And root locus is nothing but what? Possible location of closed loop poles. And whenever closed loop poles are in the right half of the S-plane, it tells us about negative damping in the system or a unstable system. So here it's not asymptotically stable, that for no any value of gain k, you can have a stable system, because we will see how to find out that value of gain k. We can see that your root locus branch intersects no imaginary axis here, and similarly another branch intersects imaginary axis here. So we can find out the values of gain k corresponding to intersection of what? The root locus branch with imaginary axis. How no, to do that? So, or should we do it here only first, or let us move further? We will come back, right, in a more exhaustive problem. So let us go to rule number 6. I think it's simple. It's clear to most of you. So let me clear it. Do you hear any voice other than me also here today?
No, sir.
Oh, I have a new neighbor. Sri Lalita madam has joined, has occupied one cabin near to mine. Her class is also at same hour. She's also taking online class. Okay, friends. Now let us look to next rule. Rule number 6. The breakaway and break-in points. How to obtain the breakaway and break-in points. So it's very simple. What we do, we know that the root locus no branches which started at no real axis on open loop poles on real axis. It's not necessary that always root locus branches will originate at real axis only. Incidentally, so far the open loop poles were on real axis, but if open loop poles are complex, then root locus branches will originate at those complex point in S plane. Anyway, now let us understand rule 6. Rule 6 tells us that the point when or the value of k when the root locus branches either leave root locus, the such points are called as breakaway points, or enter real axis, such points are called as break in points. So here where is break away point? This is breakaway point somewhere between -1 and -2, right? So you have two, this is an example of which root locus directly I have no got before you. It's there in nice also. Now the two branches, they originated at open loop uh, pole at -1 and -2, and these two branches will be progressing no towards each other, pointing to each other, and at some point between -1 and -2 they will no have to leave. Now the point at which they leave the real axis, that point is called as breakaway point. And you see the branches which have no become complex, they are now in this case, normally once they leave real axis, in many examples you will see they don't return back to real axis, but that all depends on the no open loop transfer function gshs. Here you see there are two open loop zeros on the positive real axis, right? We have at 3 and 5 two open loop zeros. So these two branches, they have no finite open loop zero at which they will terminate. Ben, can you quickly tell me what is GSHS here? Looking from the given root locus plot.
A into S minus 3.
GSHS, when I'm using desktop, ink is spreading little. Yeah, tell me, Ben, sorry. Yes,
Oh, K into
very good. Yes,
S minus 3.
very good. Zero
S minus 5.
factors is minus one. Very good. These are the zeros, right? So
Yes, sir. And poles are minus 2. So S plus 2 and S plus 1 in the
poles
denominator.
are S
Plus 2.
and S plus 2, right? Good.
Yes.
So this is how you obtain the open loop transfer function for the no given root locus plot. Now here tell me how many asymptotes or how many branches of root locus will terminate at infinity?
None, sir.
None, zero. No branch has to go to infinity because there are two finite open loop zeros, and the two branches which originated at no -1 with k equal to 0 and another at -2 with k equal to 0, they will terminate at one will terminate at 5, right? With k equal to infinity, another will terminate at open loop 0 s equal to 3 with k equal to what? Infinity. So this is how the branches will go. So for all this, k will be no greater than what? 0. Once no it has left the open loop poles, right? As k increases, becomes more than 0, the branches leave their no origin and they start moving further. Okay, so none of the branches terminate to or move to infinity. That means number of asymptotes here will be zero, since they have open loop zeros for them to terminate for the two branches. Now the point is, at what point on real axis? See, does any point between 0 and -1 lies on root locus? No, no point between 0 and -1 will lie on root locus, since the number of open loop poles and zeros to their right is 0, and 0 is a even number. Whereas between -1 and -2, all points of real axis will be part of root locus, because for them to their right, the number of open loop poles and zero is what? 1 in this case, right? No, is what? Yeah, I was wrong. Ben, why no point between 0 and -1 lies on root locus? Because to their right,
Two zeros are there.
yeah, there are two open loop zeros. I said 0, right? No, no. There are two open loop zeros. One is at 3, one is at 5. So none of this between 0 and -1, or between 3 and 0. See, friends, the part of real axis from 3 to -1 will not be part of root locus, because for all these points, the number of open loop poles and zeros to the right is 2 here, right? And it should be odd for the points on real axis to be part of root locus. Whereas this points between -1 and -2 meets that criteria of having odd number of open loop poles and zeros to their right. So for them, there are three. At the same time, the points between 3 and 5 on real axis, between 3 and 5, they also will be on real axis, since to their right, the number of open loop poles and zero here is 1. That is a odd number. So this way we have identified and darkened the part or region on real axis that will be part of root locus. Now these two branches which are moving towards each other as k increases, at some value of k, at some point on real axis, they will what? Leave real axis. Now we know how to find out the point. That tells us the maximum value, uh, uh, right, of k with respect to the s, right, at which it will be what? No, leaving real axis. That will be the maximum value of k, right, at which the branches leave real axis. Maximum value for root locus on real axis. Further increase in k beyond this value, the root locus will become complex. But the maximum value of k for which root locus no just is on the brink of leaving real axis, that can be found out, strictly speaking, by dk by d sigma equal to 0, where sigma is what? Sigma is the real part of your s plane, right? But we won't get any deviation even if we take this derivative dk by ds, right, and equate this to 0. We know we always find out this no condition when you have to get the extreme or peak value for k, such that no it is leaving the real axis. So we differentiate k with s and equate that derivative to 0. This will give me some values of s, right? And that value of s at which it is no that will give me the value at which the two branches leave the real axis. Are you getting me here, friends? Yes, Ben?
Yes, sir.
So we find out these points on the real axis where the root locus leaves real axis, right, and becomes complex. At the same time, we find the point on real axis where the two branches, they enter uh, and meet real axis, right? The points, this point at which the root locus is no from being a complex quantity is becoming what now? Real, right? This point is called as break in point. This point is called as what? break in point, whereas this point where the root locus being real before no it uh, and uh, tends to become complex is called as what? Break away point. This is called as break away point, right? There are both break away and break in points we will get by what? No, knowing this result dk by d sigma equal to 0 or dk by ds equal to 0. Good friends. So can you tell me here what will be this value, friends? Can any one of you quickly do mathematics? I give you 2 3 minutes to tell me what will be the value of s. Now, where from you will get this equation dk by ds? For that, you have to again base yourself on the characteristic equation. Construct characteristic equation. Characteristic equation will be what? 1 plus gs hs equal to 0. Put the value of this, then from this get k on left hand side. So it will involve some mathematics. Let us do it here. So it will be s square plus what it will be, friends? S square plus 3s. Please correct me if I go wrong. Plus 3s plus 2, right? It will be here, this term, plus k into what? It will be s square, then it will be minus 5s, it will be minus 3s, so it will be minus 8s, and minus 3 into minus 5 is what? Plus 15, right? So equal to 0. This is what I will get, right? For given GSHS, the characteristic equation 1 plus GSHS equal to 0 will become something like this. Right, Ben? Have I done this correctly?
Yes,
Or
sir.
from this, what will be k equal to? K will be equal to, this will go on that side, right? It will be minus s cube plus 3s plus 2 divided by what? S square minus 8s plus 15, right? And now I have to take this to, this is s square, right? It is looking s cube. It is s square, Ben?
Yes, sir. It will all be in square.
S square plus 3s, right? This is 3s. The ink is spreading here in desktop. Yeah. So can you take the derivative here by u by v rule, right, Ben? And equate that to 0 and tell me what is the value of s? Because when you take dk by ds, everything will be in s, and equate that to 0, you will get two values of s. I want guys you to do this part of mathematics for me. I am waiting for 2 minutes. Find out dk by ds. Now you know what is k. Differentiate k with respect to s, and then equate that to 0. You get an equation. So you can quickly tell me what is s. Yes, Saiti, are you solving this? Yes, Saiti, are you solving this? Unmute yourself. Sachin, are you solving this? Yes, Sachin. You should unmute yourself, friends, when I ask you something. Yes, Harshini, are you solving what I gave you? dk by ds equal to 0. Harshini? Yes, Ben,
Solving, sir.
it is taking time, Ben.
Yes, sir. Last simplification.
Okay. Himanshu, are you getting some answer?
Solving, sir.
Good. Vishnu Reddy, are you getting some answer? Uttam Chaudhary, are you getting any answer? Yes, Uttam. Come on, guys. You should be no there. Simply by logging in, it should not be enough. You should listen also to class. It's very bad, pathetic. I am not losing anything, students. You have to be responsible enough. This is such a first level design course that brings out no engineering perspective for almost every field. You can't leave away it just like this. Yes, Yash. Any answer, Yash? Altaf Ahmed. Altaf, any answer? Are you solving this? Are you there, Altaf? Can you say hello?
Sir, I got both to be complex.
You got both to be what?
Complex roots.
Some mistake there. Roots? No, you are finding s, right? Yeah,
Ye-
that value. dk by
Yes, sir.
ds equal to 0.
Yeah.
Himanshu was also trying this, right? Himanshu, you also are getting complex?
Sir, I'm still solving, sir. It's getting quite complex.
Pardon?
Getting quite complex, sir.
You also
Solving,
got
sir.
complex?
Sir, I'm solving, sir. I currently didn't get the answer.
Okay. Ben, look, somewhere you may have gone wrong.
That's what, sir. I've gone
Yes, sir.
somewhere
I'm
wrong.
also seeing.
Yeah, yeah. See, let me also solve this. Here it's coming out to be somewhere, no, how much it is? Minus 1.5 as break-in point, breakaway point, and around close to 4, right? It is break-in point. You will get this, don't worry. 100% you will get it, right? Just look into that. So let me see what is no here next thing. Rule number 7, should I present, or should we do that quickly? Let us complete here only then. Okay. Yes, Ben, any answer?
I'm still checking, sir.
Okay. So what you are getting here, k is, this is what, s square, right? S square minus 8s plus 15, right? So that is what I got, k equal to. Okay, in numerator it is minus. So dk by ds, what will be it be becoming for me? Dk by ds. Anyone got answer? Please let me know. So this denominator, right, will be square. Then denominator, what is denominator? Denominator is, let me write it as d only. Then derivative of numerator. What is derivative of numerator? It is minus, you have to consider here, remember. So it becomes minus 2s, right? Then minus 3, right? We are differentiating with s. So
So
minus
that
2.
doesn't matter. You're anyway equating it to 0.
No, no, why it does not matter in numerator? Numerator you have to solve, na, friend. This d square will go to 0, right? You are equating that to 0. Okay, so minus 2s minus 3, then minus numerator. What is this? Numerator into derivative of denominator. That will be 2s minus 8, right? So this is what you got. Now equate this. This is complete for this. Then equate this to 0. So d square will go there, right? So now you have to solve d. This you have to solve now. So some terms will cancel. And what is d? D is s square minus 8s plus 15, right? So what will be into minus 2s? You have to solve this now. Yeah. So minus 2s से multiply कीजिए पहले. It will be now minus 2s cube, then plus 16s square, then minus 30s. Now multiply d with minus 3. So it will be minus 3s square, then plus 24s, then minus 15, right? Then you have to multiply minus, keep it as it is in bracket, then multiply numerator with 2s. Now what is numerator? Numerator is already minus. यहाँ पे
So that
गलती
is
हुआ है.
minus 45, no, sir?
Which one?
The last term.
This.
45, 3, 3 into
Sir,
15.
it's minus 45, sir.
Yeah, this will be minus 45. Correct. Yeah. So now you are multiplying n, right? 2s with n. This minus sign I have kept outside. What is n here? N is this complete. Minus sign will come in here, right? I have to include this. So 2s into minus s square. It will be what? 2s. 2s into minus s square will be minus 2s cube. Then 2s into minus 3s will be minus 6s square. Then 2s into minus 2 will be minus 4s. Then minus 8 into uh, minus s square. It will be minus 8s square. Then minus 8 into minus 3 will be minus 24s. And sorry, minus 8 into minus, it will be plus, not minus. You are not correcting me, Ben. Then minus 8 into minus 3 will be plus 24. Then minus 8 into minus 2 will be what? Plus 16, right? This bracket equal to 0. So this is minus 2s cube. Now simplify, friends. I want you guys to simplify quickly. We are running out of time for this mathematics. I thought you will quickly tell me the answer. So let me rearrange this here, minus 2s cube, then 16s square minus 3s square is plus 13s square, right? Then minus 30s plus 24s is how much? Minus 6s. Then that's what? Constant number here is what? Minus 20, minus 45. So minus 45 the constant number. Then minus sign as it is, and this bracket. This is minus 2s cube, then minus 6s square plus 8s square will be plus 2s square. Then minus 4s plus 24s will be plus 20s and plus 16. Are you getting like this only, Ben?
Sir,
Are you
I
there?
simplified it
Sir,
in a bit
5.
different manner.
Sir,
So now,
5s.
yeah, just let me finish it up, Himanshu. So minus 2s cube, and this becomes plus 2s cube gets cancelled. 13s square, it becomes minus 2s square. 13 minus 2 will be 11s square. Then I have minus 6s, and here it will be minus 20s. This is 20, right, Himanshu? So minus 6 into minus 6 and minus 20 will become minus 26s, right? And here it is minus 45, here it is minus 16. So it will become minus 55, minus 61. Are you getting this equation, Ben,
Yes,
Himanshu?
sir.
Yes, sir.
So for this, we are getting complex roots.
Now, this is what you are getting, right? So S1 and 2, what it will be? Minus B, right? Minus B means it will be plus 26 plus minus under root of B square. B square is what? 26 square minus 4AC. 4 into 11 is 44. 44 into 61. 44 into 61. This is more than 26 square by 2A. A is what? 11. So it will be 22. So solve this. Under root is 26 square less than 44 into 61. Yes, Ben? You guys have gone?
No, sir, I just put it in the calculator, this equation, so I got complex roots.
You solve this. Let us meet again, okay? We are approaching deadline, you know?
Yes, sir.
Time limit. You will get that. All of you, I will also check it out. Chalo, take care. I will make some announcements for assignment by today evening.